Hey guys, thanks for hitting the play button. Today we're going to be doing a little bit of a math lesson. We're going to be talking about a calculated value called pressure velocity. But once it's understood, it's a quick and valuable tool to let you decide what type of seal to use. Let's get started. So, whether we're designing for a rotary or a reciprocating application, we have to look at the two major parameters of applied pressure and speed. It's the combination of these two values that determines whether we can recommend a suitable design. The higher the PV value, the faster the seal will wear out. Extreme values can lead to catastrophic failure. Typically, high PV values are seen in rotary applications, so let's take a look at that situation. First, we need to figure out how fast we are going. Take the shaft diameter and multiply that by the shaft speed, and then by pi. Divide that value by 12 to get our velocity in surface feet per minute. Finally, multiply that number by the pressure to get the PV. For an example, let's use 2.5 inches for a shaft diameter, 2,000 RPM and 50 PSI. That gets us a PV just over 65,000. For a reciprocating application, take the stroke length multiplied by the cycles per minute and then by 2 to get the total travel length. Divide that value by 12 to get our velocity in surface feet per minute. Again, we multiply that number by the pressure to get the PV. For an example, let's use a stroke length of 3 inches, 120 cycles per minute, and a pressure of 50 psi, for a PV of 3,000. So what kind of PV are we looking for? Choosing a seal just based on the PV value is not an exact science. There's other things like heat, contamination, hardware misalignment that will ultimately change our decision. In general, a PV of 100,000 is a baseline for success for a positive contact PTFE lip seal. It's possible to go as high as 200,000 PV, but more discussion is required with our engineering staff. Now, let's go back to our rotary example and see what happens when we raise the pressure. At 75 psi, we still look pretty good. At 100 psi, we're starting to sweat a little. And at 200 psi, we would expect severe wear to occur. As you can see, determining the PV of an application gives us a really good place to start, but it doesn't give us the whole picture. So we encourage you to reach out to our engineering group or visit our website for more information. Thanks for tuning in, guys. We'll see you next time.